I had a friend who used to teach biology at Wake Tech, and I hope whatever I'm about to say right now, like every time this video plays, she twitches because of how wrong it probably is. So let's start simple. Let's talk about sugars and carbohydrates. Specifically, we're going to talk about saccharides. So saccharides are going to represent basically our full gambit of sugars. Put a whole bunch of them together, we get the polysaccharides, or what we traditionally think of carbohydrates, or we can have mono and disaccharides, which are more what we think of in terms of simple sugars. Now, our saccharides are going to come in two flavors, aldoses and ketoses. Now, I was actually kind of surprised when I was learning this. That actually is a pretty good naming system. I kind of got off some other naming systems I was learning in parallel. I was like, man, this actually kind of makes sense. So what is a saccharide, a single unit? Well, there are two ways we can draw the saccharide. We can draw it in terms of a linear chain, or we can draw it in terms of what will eventually form are the loops, for lack of a better term right now. So we're going to start with the Fischer projection and eventually work our way back to the Haworth projection. But the aldoses and ketoses share one thing in common. We have a carbon backbone that's composed of multiple alcohols, generally one alcohol per carbon, but we don't always have to have that. And again, we're just going to kind of start simple here. So what makes it an aldose versus a ketose? Well, think about it. What compounds start with the ald and the ket? The aldehydes and the ketones, and that's the difference between the aldoses and the ketoses. The aldoses terminate on an aldehyde. The ketoses are going to terminate on a ketone. Now, when we draw the Fischer projection of the aldoses and ketoses, generally when we talk about Fischer projections early on, we sit back and say it doesn't matter which way you do it as long as it's correct with the drawing. Here we have a very specific way we have to draw it. And the reason we have to draw it this way is it's going to help us with the D and L notation, which we'll talk about in the next video. So whenever you draw an aldose or a ketose in the linear form using a Fischer projection, you're going to want to keep the aldehyde and ketone functionalities at the very top, because what it's going to do is that it's going to give us a consistent representation of these bottom carbons. And it's these bottom carbons that we're going to use to determine if we have a D or an L aldose or ketose.